All right, so this section we're going to look at linear and absolute value inequalities. So let's take a look let's just get started with some examples. So it says solve, write your solution in interval notation, and graph it. All right, so let's go over a few things with solving inequalities. It's just like solving an equation. You want to get x on one side by itself and everything else on the other side. The difference is instead of an equal sign, you're going to have an inequality sign. You'll either have a less than or equal to, a greater than, or a greater than or equal to symbol. And you just get x on one side, everything else on the other side. Now, to solve these things, it's similar to what you can do with solving an equation. You can add, subtract, multiply, and divide the same number to both sides of the inequality symbol. The difference is if you multiply both sides of the inequality by a negative number. If you multiply or divide a negative number to both sides of the inequality, you have to reverse the inequality symbol. Okay? So let's just go ahead and get started. So here, I'm going to add 9 to both sides. So I get negative 3x is less than 9. Then I'm going to divide both sides by negative 3. So I get x. Now, notice I divided both sides by negative 3. So that means I have to reverse the inequality symbol. Change it from less than to greater than. And that is greater than negative 3. Now, what they want us to do is graph our solution, and they want us to write it in interval notation. Well, let's graph it first, okay? Because I think once you graph it, it makes it easier to write it in interval notation. So let's draw us a number line here. And I've got 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. All right, so to graph it, well, it says x is greater than negative 3. So greater than negative 3 is everything to the right. So that means from negative 3, it's everything to the right. Now what you'll do is, I know, like when you're taking a test or doing your homework, you probably won't have different colored pens and pencils. So what you can do is just make it a lot, just make this thicker on the number line so your teacher can see what's going on. Now, let's look at this. It says x is greater than negative 3. So notice it doesn't say greater than or equal to. So that means on this, it's not saying that x is equal to negative 3. It says it's everything larger than negative 3. So that means it's not including negative 3. So what we do there is we put a parenthesis on the end, and that means that it does not include the negative 3. Now, let me just do this too, because this is another way to draw it. So it is everything larger than negative 3, and the negative 3 is not included. And you could use an open circle. The open circle means the negative 3 is not included. Okay? So either way, whether you put the parenthesis or the open circle to not include the negative 3, either way is correct. Okay? back when I was taking math classes and stuff, I learned to do it with an open circle. But what I've noticed now is a lot of the textbooks are using the parenthesis instead of the open circle. But either one is correct. Okay, it makes no difference. Now for me, in this video, I mean, normally I would use an open circle normally. But for the video, I'm going to use the parenthesis because the book that I'm teaching out of right now, it uses an open parenthesis, and several of the other books that I've used have been using parenthesis instead of an open circle. So I'm just going to use the open circle. All right, so there's the graph. Now let's write our answer in interval notation. So your interval notation consists of two things. It's from the smallest to the largest, and it's separated by a comma. So we're going from -3, and this line is going to infinity. And the line is going to infinity. So it's from -3 to infinity. Now, is the -3 included? No. So it has a parenthesis on it, and the infinity has a parenthesis on it. And this is your interval notation. Okay, and I'm guessing that's why they use the parenthesis, and then you'll see in a minute a bracket to do the graphs, because that's how you're doing the interval notation. That's my guess. All right, so let's take a look at the next one. So we've got another inequality to solve. We want to get x on one side by itself, everything else on the other side. So we have fractions. Well, this is no different than when you were solving equations. When you were solving an equation and you had fractions, what did you do? You got rid of the fractions, didn't you? And how do you get rid of the fractions? You multiply everything through by the common denominator. So I'm going to multiply everything by the common denominator, which is 4. All right. So that's going to leave me with a 2. So I've got 2x minus 12 greater than or equal to, the 4 cancels. That's x plus 8. All right. And so now, let's see. Let's add 12 to both sides. Let's subtract x to both sides. And so that's going to be x is greater than or equal to 20. All right. So that's my solution. So let's draw our number line to graph it. So let's see, 20, and then that's 19, 18, 21, 22. And then let's draw our line. That's everything greater than or equal to 20. So that's everything from 20 to the right. Now, in this one, is the 20 included? Yes, the 20 is included in this one. Okay? So that means we put a bracket there. All right? If the number's included, you put a bracket. If it's not included, you put a parenthesis. And then the same thing, if you have 18, 19, 20, 21, and let's say you're graphing this, that's greater than 20, so that's everything to the right. The 20 is included, so that means we will have a closed-in circle. So either way that you want to graph these things, it doesn't matter, okay? You can use the bracket or you can use the closed-in circle, okay? Either one's acceptable, okay? But like I said throughout the video, I will use parentheses and brackets to do the graphs. Now let's write our answer in interval notation. So our answer in interval notation, that's everything from 20 to infinity. Now, in this case, the 20 is included, so that means I put a bracket on the 20, and then I have my parenthesis there on the infinity. Infinity, negative infinity, they're going to always have parentheses on them. You can't ever equal infinity or negative infinity. So they're going to have parentheses on them, regardless if it's less than, equal to, greater than or equal to. All right. All right, so let's look at this one. So I'll tell you what. Well, no, let's just go to this one. All right. So let A equal the interval 1 to 5, B 3 to 7, and C 6 to infinity. And they want us to write each of these sets in interval notation. All right, so we've got A. Let's do A first. So A, we've got A union B, or you can say A or B. And this, see, that's the union. This is intersection, A intersect B, or you could say A and B. All right, so to do this, the best thing to do is just graph the two sets. All right, so we're doing A and B, so we've got to be able to take in the number 1 and the number 7. So we've got 0, 1, 2, 3, 4, 5, 6, 7, and 8. All right, now what I would do here is graph the A. That's everything from 1 to 5. Okay, don't graph it on the line because that's not your final answer. All right, so the A and the B, graph it above the line. B is 3 to 7, so that's everything from 3 to 7. All right, now we've got A union B, so we've got A or B. So when it's separated with or union, your answer is everywhere there's a line. Okay, so you can see that we have a line starting at 1 and it keeps going, and it jumps down to here and it goes to 7. So everywhere there's a line, that is from 1 to 7, and we're going to have parentheses on the ends. Okay, so A union B, let me erase that. A union B would be the interval 1 to 7. And that's your answer. All right, so let's look at the next one. So we want to do A intersect B. So this is part B. And so let's do the same thing. 0, 1, 2, 3, 4, 5, 6, 7, 8. And let's graph each one of them above the line. Okay, the A and the B, graph them above the line. And so A, well, once again, that's 1 to 5. And then B is 3 to 7. Okay. And this time we want A intersect B. So that's A and B. So that is what they have in common. Okay. That's what they have in common. So in other words, that's where the lines overlap. And you can see they overlap here. That's where they overlap in here. So that's from 3 to 5. And see, we're going to have a bracket here on the 3 because the 3 is included on both of them. But here on the 5, we'll have a parenthesis because the 5's not included on this blue line up here. Okay? And so this would be 3 to 5. All right. Let's look at C. So let's draw our number line. And let's see, we've got to be able to take in 1 to 6, well, more than 6, but 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's just go to 9. All right, now let's graph A. So A is 1 to 5. So that's 1 to 5, parentheses on both ends. And then C is 6 to infinity. So that's 6 to infinity. Now, this is separated with or, so it's everywhere there is a line, which is here, and then it jumps down to here. So our graph would look like that. Okay? Everywhere there's a line because it's separated by or. And so our interval notation is 1 to 5 union 6 to infinity. And there's your answer. All right. All right, so let's do the last one. This is D. Draw our number line again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then let's graph A. That is 1 to 5. C is 6 to infinity. All right. Now this is A intersects C. So that's where the two graphs overlap. So where do they overlap? Well, they don't overlap anywhere, do they? They have nothing in common. So this would be the empty set, no solution. Okay, they don't overlap anywhere. All right. All right. Now, let's look at this. Solve each compound inequality. Write solution in interval notation and graph it. So we've got two inequalities. We've got 2x minus 3 is greater than 5 and 4 minus x is less than or equal to 3. Well, to work this one, we kind of do it like we did the first examples that we worked. We just first solve each one of them individually. Okay, so let's do that. So I'm going to add 3 to both sides. So I get 2x is greater than 8. And then I'll divide both sides by 2. And so that's x greater than 4. All right. Now this one, I'm going to subtract 4 to both sides. So I get negative x is less than or equal to negative 1. Divide both sides by negative 1. I divided both sides by a negative number. So that means I have to reverse the inequality symbol. Okay. Now, this is separated by and. All right. So to graph this, well, guess what? We're going to do just like we did before. I've got to be able to take in 1 and 4, so let's do 0, 1, 2, 3, 4, and 5. Now, to graph them, let's do just like we did the ones previously. So I've got x greater than 4, So let's graph that. Okay. Just graph both of them above the line, and then x greater than or equal to 1. Now, let me do that one let's do it in a different color. And so I've got x greater than or equal to 1. So my final solution, well, it's separated by and. Okay, separated by and. So that is where the two graphs intersect each other, or that's where they overlap. Well, you can see they overlap right here. So that's from 4 to infinity. Now, notice on this blue line up here, the 4 is not included. So they don't have the 4 in common. So it goes up to 4, but does not include the 4. So that's going to have a parenthesis on it. And so that would be your graph. And then you've got to write this answer in interval notation. And so that's going to be 4 to infinity. And so there's your interval notation, and this is your graph. All right, let's look at the next one. All right, so once again, just like before, solve each one of them individually. So I'm going to subtract 4 to both sides. So I get negative 3x is less than negative 6. Divide both sides by negative 3. So I get x is what? Greater than 2. I divided both sides by a negative number. Remember, anytime you multiply or divide both sides by a negative number, you have to reverse the inequality symbol. And now let's solve this one. So I'm going to clear the parentheses. 3x minus 6 less than or equal to negative 6. And then I'm going to add 6 to both sides. And so I get 3x is less than or equal to 0. Then I'll divide both sides by 3. So I get x is less than or equal to 0. Now, to graph these things, so I've got negative 1, 0, 1, 2, 3. And just like before, and well, let me go ahead and write this. This is separated by or. So let's graph them above the line. So I've got x greater than 2. So that's this one. I've got x less than or equal to 0. So that's going to be this graph, less than or equal to 0. That's everything to the left. Now let's put them together. This is separated by or. So our final graph, that's going to be everywhere there's a number, everywhere there's a line, because it's separated by or. So that's going to be from 0 back to negative infinity, and 2, it'll have a parenthesis on it because the 2's not included, back this way. Now, let's write our answer in interval notation. So it's everything from where? It's starting at negative infinity, right? Negative infinity. And it's going all the way up to 0, and the 0 is included. And remember, we'll have a parenthesis on plus or minus infinity. Union, okay, or, so union, everything from, now this one, 2 to infinity. And there's your answer in interval notation, and here's your graph. All right, how about this one? All right, so for this one, well, now this one looks kind of weird, doesn't it? It's got more than one inequality symbol in there. And let me say this, it's no different. It's no different than what we've been doing. We're solving this, so let's look at it. So let's just pretend like this, this negative 4 less than or equal to, pretend like that's not even there. Just pretend like you're solving this. Okay, just pretend like you're solving that. If you were solving this, what would you do? You would add 1 to both sides, right? To get x by itself. Okay, well, that's what you do. You just add it to all 3 parts. You want to get x in the middle and everything else on the left and right hand side. Okay, so add 1 to all 3 parts. That gives us -3 less than or equal to 3x less than 6. And then we got to get rid of the 3, so I'm going to divide by 3. So that means I do it to all 3 parts. So that's -1 less than or equal to x less than 2. All right. So now let's graph this thing. So that's going to be let's start out with -2, -1, 0, 1, 2, 3. All right, now here on this one, you don't really need to draw 2, separate graphs like we did up here in these and then combine them into one. Look, all this means right here is that x is between -1 and 2. That's all it means. So x is between -1 and 2. Is the -1 included? Yes, because it has the line underneath. So that's going to be a bracket. Is the 2 included? No. So that's going to have a parenthesis. So there's your graph. And then your interval notation is going to be what? -1 to 2. And the -1 will have a bracket on it because it's included. The 2 will have a parenthesis because it's not included. Okay. All right, so how about this one? All right, so once again, let's solve each one of them individually. So I'm going to add 9. So I get 3x is less than or equal to 18. Divide both sides by 3. X is less than or equal to 6. And then this one, let's subtract 4 to both sides. And so I get -x is less than or equal to -1. Divide both sides by -1. X is greater than or equal to 1. Okay, don't forget, multiply or divide both sides by a negative number. You've got to reverse the inequality symbol, and this is separated with or. So let's graph. All right, so let's graph them separately. So x is less than or equal to 6. So that's everything from 6 back to the left. X greater than or equal to 1. So that's everything from 1 back to infinity. Now, remember, or, that is everywhere there's a line. So you can see there's a line that goes all the way back to -infinity, and it's coming up, and there's a line, here's the line, and it's going all the way to infinity. So you can see there's a line everywhere. Okay, there's a line everywhere. So our graph is just the entire number line. Okay, because both of these lines combined cover the entire number line. All right, so there's your graph. So our interval notation is what? -infinity to +infinity. Okay, now, I know a lot of these problems say, solve it, write your answer in interval notation, graph it, and a lot of people try to put it in interval notation and then graph it. I think, and that's fine if you do that. I just think it's easier if you graph it and then write it in interval notation. The graph helps you see it better. All right, so how about this one? All right, so this one's separated by and. So let's solve it. So this one's a little different. I mean, well, not really. I wouldn't say different, but of what we're going to do. So normally when we see fractions, we multiply through by the common denominator, right? So let's just forget about this problem right now and just look at this. Say 2/5 x equals, I don't know, say 10. Okay, so one way we know to do it is multiply everything by 5, so that's 2x equal 50, and then divide everything by 2, x equal 25, and that's fine and everything. You can do that. Okay, but something, let me show you this. when we're solving these things, and I know I have an equal sign there, the same thing applies. So when I'm looking at this, I need a 1 in front of x, right? So what if I just multiplied everything by the reciprocal, right? Because isn't that canceling those out and we're left with just x, and then that's what? That's 5, and that's 25. See, it's the same thing. Now, before, when we had fractions, we would multiply through by the common denominator. But if you notice, let's go back to that problem. That's this one right here. Notice how we had more than one term on each side. Okay? We had more than one term on a side. But in this one down here, we've just got one term on this side, one term on this side. If that's the case, and you have a fraction, then what I would do is I would just take the reciprocal of this, which is -3/2, and multiply both sides by the reciprocal. Now, the reciprocal, when I'm multiplying both sides by what? A negative number, right? So that means I have to reverse the inequality symbol, right? Everybody see that? All right, so let's take a look. We get what? This is 1. See, -3/2 times -2/3 is 1, so that's just 1x greater than, and then that's going to cancel. I'm left with 2. That's -6. All right. Now let's look at this one. Same thing here. I'm going to multiply both sides by what? The reciprocal of what's in front of x, which is 4/3. So that's going to be 4/3 times 3/4 x less than 4/3 times -6. All right, so those cancel. That goes to 1x. And then that cancels with that. That's -2 and 1. So that is less than -8. All right. Now, let me say this. If this confused you, me multiplying both sides by the reciprocal of what's in front of x, I'm showing you this because it's fewer steps when you do it like this. But if this confuses you, then just go ahead and multiply everything through by 3 and then come back and divide both sides by -2. Or here, multiply both sides by 4. Write that down and then divide both sides by 3. That's fine. There's nothing wrong with doing that. Okay? And this is separated by and. All right, so let's see what we've got. Let's see, we got -9, -8, -7, -6, -5. All right, now let's graph each one of them individually. So x greater than -6, that's that. X less than -8. All right. All right. So we've got and, which is the intersection. So that's what they have in common. Or in other words, where do the lines overlap? Well, they don't overlap anywhere, do they? Okay. So this is no, so this one has no solution. You could write empty set. All right. Okay, so now let's go to absolute value inequalities. So there was a lesson before this on linear equations. It was linear, rational, and absolute value equations. It's in this playlist. You can go back and watch it. It's the problems towards the end of the video, where we solved equations with absolute value equations. Just to refresh your memory, when you had the absolute value of x equal k, then we would rewrite it as x equal k or x equal negative k. That was absolute value equations. But you can see here we've got absolute value inequalities. But it's the same process. When you have this form, we had to do what? We had to rewrite it into this, didn't we? Well, that's the same thing here. When you have this form, we have to rewrite it into this. All right. So with the absolute value inequalities, if you don't know this, then you can't work the problems. Okay. So I'm gonna try and show you a easy way to rewrite these things. It's all based on the symbol. See, less than, or equal to, they're written in the same way. Greater than, or equal to, they're written in the same way. Look, these two here, they're the same thing. It's just showing you that it doesn't matter if it has the line underneath or not. They transfer, they can be rewritten the same way. Same thing here. It doesn't matter if it has a line under it or not. They're both written the same way. One has a line and one doesn't. Okay, that's the only difference in these two and then these two together. That's the difference. So you can see what's inside the absolute value here. On the first two, what's inside the absolute value, that goes in the middle, and then k goes on either side. And then for the greater than, it's broken up into two parts. Okay, so let's just look at this. All right, so let's look at finding absolute value, or solving absolute value inequalities. So here, if you remember, all right, so let's look at an example. All right, so let's look at an example. It says solve, write solution in interval notation, and graph it. So I've got the absolute value of 3x plus 2 is less than 7. Okay, now to solve this, we need to rewrite it just like when you did the solving the absolute value equations. So we got to rewrite these things. Now let me show you the easy way to do it. So you can see here, basically all you're doing, look, let's erase that negative. So it's just what's in here, what's inside the absolute value is written here, and then the k is written on each end, where this k has a negative in front of it. And that's it. Okay, so let's do that. So we've got 7 less than 3x plus 2 less than 7. So I just wrote the k on each end and what's inside the absolute value in the middle. And then this k over here has a negative in front. And that's all it is. Okay, now we solve just like earlier. Okay, solve it just like you did earlier. So let's get the x in the middle. So I subtract 2 to both sides. And so I get negative 9 less than 3x plus 2 less than 5. No, I'm sorry. Less than 5. The 2's no longer there. We subtracted it to both sides, or all three parts. Now, let's divide everything by 3. And so I get -3 less than x less than 5/3. All right. So now, don't freak out here because you ended up with a fraction as part of your answer. All right. So let's just look at it. Let's draw our number line. So let's graph it. So we've got -4, -3, -2, -1, 0, 1, 2, 3. All right, so our solution is everything from -3 to 5/3, but, well, we don't see the 5/3 on the number line, do we? Well, let's see, 3 goes into 5 how many times? 1 point something, right? It doesn't go in 2 times, but it goes in, when you do 5 divided by 3, you get 1 point something. So we know that 5/3 falls in between 1 and 2. So just put it in there and label it. And so our solution is from -3, and the -3 is not included, all the way up to 5/3, and the 5/3 is not included either. We write our answer in interval notation. That's -3 to 5/3. And this is our answer. Okay? All right, so if it kind of looks, if the video kind of seems like it jumped from one thing to another, that's because I was recording and I paused because I had to cough. And then I started working back and forgot to resume the recording. So I basically went back to this example here, which I think I recorded it, but I'm not sure. But I just went back to this example and just started there, and I'm going to cut out that part where it kind of messed up. So if it looks funny jumping from one thing to another and it may not make sense, that's what happened. All right, so let's look at this. So we have another inequality. Now, how would we go about solving this one? Or let me ask you this, which one of these is it? Okay, which one is it? Well, a lot of students on this one, they look at that less than or equal to and say, well, it's this second one right here. Well, that's not the case, because if you notice in all of these right here, the absolute value's on one side by itself. So before we can decide which one to use, we've got to get this absolute value by itself. So I'm going to subtract 4 to both sides, and so that gives me -2 absolute value 4 minus x less than or equal to -4. And then I'll divide everything by -2. So that's absolute 4 minus x. Now, I divided both sides by -2, so I have to reverse the inequality symbol. Okay? All right, so now we've got greater than or equal to. And so that is this one right here. Okay? So look, all you're doing is taking this right here, taking this and rewriting it without the absolute value. That's all it is. And then put or, and then rewrite it again. See what's inside the absolute value. But then, well, let me see, that should be an equal to there. So just write what's inside the absolute value and then reverse this symbol and put a negative in front of k. So it's written without the absolute value, and then write it again, but flip the symbol and put a negative in front of k. And so that's what we're going to do here. We get what? 4 minus x is greater than or equal to 2. Write it without the absolute value. Or, and then write it again, but reverse the symbol and change the sign of k. And that's how you do it. And now this is similar to one we worked earlier, right? Similar to one we worked earlier. So we just solve each one. And so let's subtract 4 to both sides. And so that's going to give me -x greater than or equal to -2. And then I'm going to divide both sides by -1. And so that's x less than or equal to 2. We divided both sides by a negative number again, so we have to reverse the symbol. And then I'm going to subtract 4 to both sides. And that's going to give me negative x is less than or equal to not negative 8, negative 6. And then I'll divide both sides by negative 1. And so I get x is greater than or equal to 6. All right. And let me take this. These are the last two problems, but let me move them down. All right. And this is separated with or. Okay. So my solution and you could graph them each separately, but this one is just what? X less than or equal to 2 and x greater than or equal to 6. There's your graph. Remember, it's everywhere there's a line. I mean, this is what it would look like if you graphed them separately, right? If you graphed each one of them separately like we did before, and then your final answer is everywhere there's a line, so that would be your graph. And so now we write this in interval notation. Well, that's everything from negative infinity to 2, and it's going to have a bracket, union everything from 6 to positive infinity. There's your interval notation. All right, now let's look at these. So if we look at this one, we've got absolute value of x minus 3 is less than negative 2. All right, so which one is that one? Well, a lot of times students say it's that one, but it's not. Because these only apply when k is positive, okay? So you can see here k is negative, k is not positive. So those properties, those rules up there, they don't apply. So now we've got to actually think about it, okay? We got to think about it. So let's look at this. Now, do you agree with me on this? This side over here, all of that, will always be positive, right? It doesn't matter what we plug in for x, okay? We're taking the absolute value, okay? I mean, no matter what number you plug in for x, you might get a positive or a negative number in here with the x minus 3. Whether it's positive or negative, then we're going to take the absolute value. So this left-hand side will always be positive, right? So there's no way that it can ever be less than negative 2, right? And so this one has no solution because there's nothing that would work, all right? Now, what about this one? Absolute value of x minus 3 is greater than negative 2. So let's find everything that works. Well, no matter what we plug in for x, I mean, it's the same argument as I made over here. This side over here will always be positive, right? Always. So this is always going to be larger than negative 2, and that's what they want to know. When is it larger than negative 2? Well, it's always larger than negative 2. So the solution is all real numbers. It's everything. So if we graph that, that's going to be the entire number line. And our interval notation is negative infinity to positive infinity. Okay. All right. So I hope all that made sense. I hope the video looks okay after I cut everything out and all that stuff. So I'll know when I end the video. So, but anyway, I hope all this helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.